Welcome to the shop. I'm continuing in NQALHA production run 4, making 750 parts. That's a lot of parts. So today, I'm going to be doing a slightly different procedure than I've done before. Little bit by little bit, I'm optimizing and perfecting toolpath and trying to speed up cycle time without adversely affecting quality. So these are known trusted toolpaths that I kind of looked at this morning and thought, you know, I can combine two parts that are very similar parts. They're the top and bottom head pivot, and they're made out of the same kind of stock. They use the same kind of fixturing to hold them, and more importantly, they use the same cutters to cut them. So I should be able to do the first operation on two different parts in the left and right vise without having to do excessive tool changes. So these parts are slightly different from my normal setup. In my normal setup, I clamp a blank in one vise and then drill holes in it and mill things out, then put it on the tooling plate for the second operation. For this part, it's a little bit different. The first operation is done on a tooling plate with a clamping fixture. So let me get the screwer tool here. So the clamping fixture here holds the blank in place, and then the profile is cut. So I kind of like align, the blank is a little bit oversized, and I kind of align it a little bit, and then this holds it in place for the operation. Go over here. To the second vise, and similar to what I always do, Z0 is set on the top of the tooling plates, both left and right. Work offset 1, work offset 3, just as normal, but the somewhat different approach here is that, I make sure this guy is in place. So the somewhat different approach is that the first operation is done with the part clamped in a fixture on a tooling plate. So I'm going to go in the CAD room and do a quick check just to verify that things are looking good, and then come out, and this is going to be kind of halfway in between a known and unknown toolpath. The toolpath itself is known and trusted, but the operation of doing two parts, left and right vise, kind of intertwingling together the two G codes manually edited, has never been tested before, so I'm going to be a little bit extra careful. So off to the CAD room. Things are looking good. Going to be extra careful here because there's lots of potential for pain and failure if the cutter runs into these screws. Not only does it destroy the cutter, but it also would destroy my little clamping fixture, and that results in, you know, a little bit more work to rebuild it. So I'm going to be extra careful here. And the sequence of operations is also important. So I'm doing the first part rough, move over to the second part rough, then do the second part finish, move over to the first part finish, drill and tap a hole, and I like the tapping operation to be the last operation because I turn off the coolant, open up the door, blow off the coolant, apply tap magic, and I like that to be right before I remove the parts. So everything has a sequence, and here we go. Let's see if it works. Also, I cut the blanks off camera. I'm using aluminum extrusion. Almost all of the parts in the NQALHA project, the aluminum parts, are made out of aluminum extrusion. It works really well, it's easy to cut, and a lot of the parts were actually designed assuming that they'd be made out of aluminum extrusion. So I cut them on the aluminum cutting chop saw off camera, deburred on the Scotch-Brite wheel off camera. If you want to see how that's done, I can't imagine why anybody would want to see how that's done because it's about the most boring thing ever, but I did it in the previous videos. So cycle start. Observe that the tool change goes correctly. Moving over to the correct work offset. Single block mode. And coolant off. Throw the old eyeball on it. Looks sane. That is looking very sane. Not sure I like that shatter. And the Z-axis retract. Perfectly fine to clear the fixture. That shatter is kind of bugging me a little bit. I'm not totally sure what's going on with the chatter. This is okay, that's wrong. Not really like dangerously wrong, but looks like it's in the right place. And then verify that that retract is correct. I'm doing this is a 1/2 inch stock, and I'm taking 1/8 of an inch per pass for the roughing using the Lakeshore Carbide aluminum shredder cutter, and I haven't had, now that looks pretty good, I haven't had that kind of nasty chatter on previous parts, so I'm gonna probably do a little bit of troubleshooting here to try to figure out what's going on. single block, 3 flute, finish cutter, 15 thousandths finish pass, okay, so I've got the spindle stop and, oh, now that's interesting. Completely forgot that the other part uses a different cutter. So I guess it really only minimizes one tool change. Not sure how valuable this is, actually. And checking the clearance, make sure I don't have a clearance problem. So, things are proceeding very nicely. I need to do a little investigation of what's going on with that chatter. So, coming over to the hole, this is 832 tap drill. And it's using a full peck cycle, where usually I've switched now to a lot of fast peck cycles. I may go ahead and change that to a fast peck cycle. Okay, that's looking good. That's looking good. Power tapping on the Tormach, as I said before in previous videos. I don't use flood coolant because it doesn't really work that well. I put in a pause in the tool path so that I can add Tap Magic cutting fluid. So, except for the wasteful spindle stop and Z-axis retract, and the little bit of a mystery of where'd that chatter come from? The combo first operation works. I'm not sure it was actually worth going through the trouble of doing it, since it only minimizes one tool change, but I'm going to keep it since it's set up and it's running. I'm going to go troubleshoot the chatter, try to see if I can figure out what's going on with that, and come back again. This part here, the top head pivot, it has a little bit of trickiness going on to try to make sure that a couple of the second operation pieces are referenced correctly, and I'll be describing that when I talk about the second operation. And then the second operation on this piece, the bottom head pivot, is not really tricky. It's just kind of annoying. It's got a long hole that's drilled all the way through the 2-inch part, a number 10 clearance hole, which means a lot of pecking, a lot of going slow. Got to make sure that the chips don't build up on the cutter. So I'm going to turn the camera off and come back for second and third and fourth operations. Okay, the tool path has been optimized and corrected as good as it's going to get. It really doesn't save a tremendous lot of time, but oh well, you know, got to try something. The chatter just went away magically. Chatter on the Tormach is sometimes mysterious to understand. It may be that when the tool loaded in when the automatic tool changer loaded and the power drawbar closed, maybe that one time it didn't quite close exactly right. Maybe there was, I don't know, a tiny chip or something. I took the tool out and inspected it and wiped it off and wiped out the inside of the collet, and it didn't really look that bad. But then I ran the part again, or ran the parts again, and the chatter was gone. So chatter is sometimes very mysterious on the Tormach. Sometimes it happens, sometimes it doesn't. And that's why I take 4 passes to go through a 1/2 inch, because trying to be more aggressive, the more aggressive you try to be, the more trouble you have. So here we go. This is the full optimized tool path without stops, without interruption. Tool changer continues to operate correctly. And that's what a smooth cut sounds like. Pretty much everything's the same. 5,140 RPM, 40 inches per minute. The Lakeshore Carbide 3-flute aluminum shredder roughing cutter with flood coolant, taking 4 passes to make it through a 1/2 inch piece of 6061 aluminum. And pretty much, other than just a tool change, there are no changes to the tool path, and it's cutting smoothly today. And of course it cuts smoothly on the parts from the days previous, so the chatter was very mysterious and unexplained. Even though I have many hours of experience on the Tormach and have made thousands of parts, it still baffles me sometimes. Sounding very smooth, all is well, clearing the fixture just fine. And for those who didn't see the first video, I'm using, for this series of parts, for this run of 750 parts, I loaded up a fresh new aluminum shredder end mill, as well as a fresh new 3-flute Lakeshore Carbide 3/8 diameter finish end mill, zirconium nitride coated, because I wanted, even though the old tools were fine, I didn't throw them out. I just kind of marked them as used. I wanted to start the run with new cutters. So the chatter was almost certainly not caused by an old beat-up cutter. These things do last a pretty long time cutting aluminum. Quarter-inch 3-flute, 5,140 RPM, 30 inches per minute. The finish pass is 15 thousandths. I needed one particular inside radius on this part to be just a little bit sharper than the 3/8 tool provided, and yeah, I probably could just redo the tool path to make the part on the left finish with a 1/4 inch, but you know, probably not worth it. I could drive myself crazy trying to knock off the last second or two off the cycle time. It's always a trade-off, trying to figure out how much time do I spend optimizing. Every minute I spend optimizing is a minute I'm not making parts. Tap magic for aluminum. Move to the load position. Load up a new set of blanks. And we do it again. See you later for the exciting second, third, and fourth operations. Wow, bet you can't wait. The first operation has been completed for both of the parts, so I have 10 of each part, and this is what the part looks like, and then this is the other part. And the next step, I need to drill some holes. So this part needs to have a hole drilled, a 1032 clearance hole, number 10 drill, needs to have a hole drilled all the way through it, which will require a PEC cycle. It seems to take forever, but I can't speed it up too much because I don't want the chips to get clogged, and so it's got to do a full PEC. In order to avoid running the drill bit into the surface of the vise, the part will sit on a little spacer. So you put the spacer in place, and then go back to the CAD room because I didn't write down what the orientation was. Okay, so I probably could have guessed this because the flat side is going to be up against the stop, and doing it the other way, well, it's kind of dicey. So I still write it on the setup sheet anyway. This is work offset 2, special, somewhat taller, medium tall soft jaws, 0 at the left rear corner, and the surface of the vise. Put the part in place, and get that guy. I only use the electric tool for the first, for the rapid moves on the vise. I typically just clamp the vise down by hand. So this part has a couple of more interesting features. It needs to have a counterbore hole drilled and tapped into this part, and it's a kind of a special hole in the way that it relates to the part, and it kind of dictates how the part will be made. The hole that is going to be drilled and tapped and counterbored, there's going to be a shoulder screw that screws in here and forms the axle for the twist axis. So it's really, really important that the axle be perpendicular to the surface. Now, aluminum extrusion is a pretty reasonably high quality material, but because I'm being careful here, I can't really assume that this face of the extrusion is flat and perpendicular to the side. It might be, it might not be, it might be off by a little bit, but I don't want off by a little bit. I want it to be as good as I can possibly make it on this machine. So I put it into the vise, sitting on a custom-made precision milled spacer, and then while it's in the machine, I'm going to face the top off, just skin it off, just take a few thousandths off the top, and without removing it from the vise, drill a hole and tap the hole and counterbore the hole. So this guarantees that the drill, tap, and counterbore are perpendicular within, as good as the machine can do it, to the axes of the machine. So like many other tool paths that I've been working on in this production run, this is a known trusted tool path that's made many parts, but in order to try to save a little cycle time, I've changed the order around a little bit and done some hand editing of G-code and kind of made up a combo program that does both parts in one load cycle. And so even though it's composed of known trusted pieces, still, it's the first time that the entire combo has been run, so I'm going to be real careful. Also, I typically use the stubby drills, the shorter drills, for almost everything that I do, but in the special case where I have to drill a longer distance, I disassemble the collet and tool holder and put in a longer bit, reset the zero, and I modified the tool path a little bit because of the length of the drill. Usually when I'm using a short drill, I don't really have to worry about the tip walking around because the short drill is stiff enough that I just go and drill the hole and it comes out okay. So for this one, because I need the length to make it through the part, I'm gonna do a slightly modified drill cycle where I start out going really, really, really slow for like 20 thousandths, just barely put a little dent here, feeding at actually not 0.1, feeding at 1 inch per minute, down like 20 thousandths, just to kind of spot the end, and then proceed with the drill cycle. And hopefully this will give me a slight bit better accuracy. I mean, this part doesn't need to be like dead nuts, and the parts that I've made in the past without the special drill cycle have worked just fine. Everything fits, but I'm little bit by little bit, as I make more of these, I'm refining and tweaking and adjusting and trying to make every one just a little bit better. So here goes. Single block mode, using one of my long drills with the special cycle, and verify that Actually, I don't know. Does this one even have... Maybe this one doesn't have the special cycle. I don't know. Yeah, there it goes. And we're packing. 70 thousandths per peck, 5,140 RPM, 10 inches per minute. Doing a full peck cycle to get the chips out of this very deep hole. And yes, it does seem to take forever. I can actually drill this one faster on the Bridgeport because I can crank the old quill handle faster than the machine can rapid, but yeah, be nice if the machine had faster rapids, but oh well. The really annoying part is that Tormach introduced the new version, the 1100MX, just like a few months after I bought this guy. So and of course the 1100MX has the servos instead of stepper motors. Okay, single step mode. Pre-feed looks correct. Feed looks correct. Special cycle looks correct. Doing a fast peck because in this case I'm only going through a short amount of material. Everything's looking correct. All is well. Yeah, the 1100MX looks better in just about every way, but there is no upgrade path. So we're moving over to work offset 4, and this looks correct, to do the facing operation. Okay, pre-feed looks correct. Feed looks correct. Using the 3/8 finishing cutter because I'm not taking much off here. I'm just barely skinning the surface. But now I've generated a reference surface, and I can be pretty confident that the counterbore, drill, and tap are going to be perpendicular to that, kind of within the limitations of the machine. So here comes the counterbore. Okay, pre-feed looks correct. Feed looks correct. I'm pecking with the end mill. Another thing that I'm doing here, I want that counterbore to be a fairly precise distance from the top. And because, let me pay attention here for a moment before continuing the discussion. Okay. Because this is all being done in one operation, in one load where the part stays in the vise, I skinned off the surface and then did the counterbore so that the depth of the counterbore is going to be controlled relative to the top surface within the tolerance of the z-axis and the measurement of the tip of the tool using the tool setter. So that gives me a very good control over the depth of my counterbore. This is going to be a 1032 tapped hole, 5,140 RPM, 10 inches per minute. 60 thousandths per peck using a fast peck cycle. Getting a little bit more buildup on the drill than I'd like, but okay, that is not specifically wrong. And then I push the stop button, which is not what I wanted to do either, but that's not specifically wrong, but it's slightly out of sequence. What I really wanted to do was drill the 1032 and ⅛ tap drill holes first before putting the taps in, so I could lower down the barrier, blow away the coolant, and be standing there at the ready with the tap magic. I didn't want to do a drill, tap. I wanted to do a drill, tap, tap. So it's back to the CAD room. Nice having the CAD room right next door to the machine shop. So I got made a kind of a special here so I don't have to go through the whole cycle. So let's drill the tap drill. And yeah, that was correct. Little fast on the trigger finger there. But it's better to be fast on the trigger finger than it is to let the thing go out of control. So there's my ⅛ tap drill, and blow away the coolant. Over here to the 1032 tap, single block, verify things look happy, and like I said before, I don't like using the flood coolant with the Tormach compression tension tapping head. First of all, because the coolant only hits the body of the tool and it doesn't get down to the tap. And second of all, the Tap Magic just does a better job. Tap Magic really is magic. I saw something there that concerned me a little bit, and I'm going to look into that. I saw something there that made me a little bit concerned. At the bottom of the tapping operation, the tap kind of got stuck, and I'm a little bit uncertain about what's going on here. The tap may be programmed to go just a little too deep on this. The top hole needs to be a through hole, but this hole does not need to be a through hole, and it's likely that the tap hit the spacer, which is very definitely not a good thing. And if it didn't slip, it probably would have broken the tap. So I got some troubleshooting to do. I'm gonna go shoot that trouble. So I'm gonna go do some troubleshooting and come back and run a complete cycle at full speed on camera, and then this part will be complete, and this part requires 2 more operations, one of them done on the Tormach and the other one done on the Bridgeport. So see you later. So yeah, sure enough, the depth of the tap was actually incorrectly programmed in the toolpath, which is very surprising because I've made many, many parts with this toolpath, but it wasn't right. And how did it end up wrong? I don't know, but I think it's right now. So, the mysteries of CNC programming. So here we go. Full speed, hopefully everything just works right. Gonna still have my finger on the stop button just in case. Okay, special pre-feed, doing my peck cycle. I think it's 31 pecks. A lot of pecks. $5,140 RPM, 10 inches per minute, 70 thousandths per peck using the full retract peck cycle. And flood coolant, nicely aimed, because I don't want my drill bit getting bound up with chips and getting stuck in that hole. I'm using the highest recommended concentration of 7% of the cutting fluid. This is a semi-synthetic cutting fluid called Trim Microsol 600. And I'm using the higher concentration because the higher concentration tends to lubricate better, gives a better surface finish, prevents rust on the machine a little bit better, and according to the data sheet at least, they claim that it results in longer life in the sump. Of course, I haven't had problems with my coolant degrading. A lot of coolant manufacturers recommend using now that is not correct. Okay, so let me go back to the CAD room again. That's not correct. Oh, and I just finished my thought. A lot of coolant manufacturers recommend using soluble oil for aluminum, and I really don't like that. Soluble oil is a material that it tends to go rancid if you leave it in the sump for a long period of time. And there are months when I don't touch this machine, and I don't want to have to worry about a stinky mess in the coolant tank. So, boy, this is turning out to be a little more tricky than I thought it would be. Well, that was more painful than I thought it was going to be. The toolpath program that I use is Bobcad Cam, and it's okay. It's an inexpensive program. I can't afford the really good stuff, but Bobcad is okay, and it has some annoying frustrations. It's like, I think it just on its own changed the order of the operations. And then when I tried to change them back, it refused to let me change them back, and I had to do a whole bunch of stuff, deleting things, reinserting things. Oh, so I'm just gonna restart this cycle again. I'll probably either speed it up or edit to avoid watching all those pecs over again. But I do like to verify that it's correct, since I did make changes on it. So that finishes the boring part. Let's verify that this guy is operating correctly and nothing major has gone wrong. Skinning off the surface with the 3/8 finish end mill, the 3-flute zirconium nitride coated Lakeshore carbide running at 5140 RPM, 40 inches per minute. Okay, counter bore. Trying to precisely control the depth of the counter bore relative to the surface that I just machined. Pecking with the counter bore to try to minimize the buildup on the end of the tool. Got the stubby drill bit for the 1/4-20 tap drill, fast peck, 2000 RPM, 10 inches per minute, 60 thousandths per peck. Things are looking good. .1032 tap drill. .5140 RPM, 10 inches per minute. Fast peck, 60 thousandths per peck. Prepare for tapping operation. Now, with any luck, I changed the depth of the tapping operation so that it doesn't run into that problem at the bottom. And that looks completely correct. It's amazing how that, what I thought was a known trusted tool path, seemed to have a bit of a problem. And of course, it brings up a saying that we typically use in the software world, but I think it applies to pretty much any endeavor. And that is, what's worse than a bug that crashes the system? A bug that appears to work correctly and shows no evidence that it's incorrect. I have no idea how that tool path worked successfully for the previous parts, but that does it for second operation on these two parts. I'm going to turn the camera off, run the batch, and when I come back, we'll be doing third and fourth operation on the left part. The right part is now complete, or it will be complete when the batch is run. So see you later. So the entire run of these parts is now complete. They only required 2 operations, and they're ready to go in the vibratory finisher. This part requires some more work. requires 4 operations, and it's necessary to drill and tap a hole in this end and drill a hole here. So obviously I could drill this, flip, and drill again, but to save cycles, I'm just gonna try to get it drilled with the one drill bit, and look at that, I don't have enough stick out. So as much as I dislike excessive stick out and try to avoid it, I've actually been able to produce successful parts with this method. It does work, and I'm going to continue with it. So there. And verify. Yeah, boy, this one is close. This is probably the most critical part out of the entire project in terms of stick out and clearance. So now that I've moved the drill bit a little bit and the collet, the system no longer knows where the tip of the tool is. So I'm going to use the electronic tool setter and then go over to the tool offset screen and reset tooltip 0. I have put in the tool path the new kind of, it's not put in by the toolpath program. I put this in by hand in the G-code, where the drill bit rapids down to fairly close to the surface, then feeds at a slow speed until it touches the surface, feeds at an even slower speed, 1 inch per minute, and goes down like 20 thousandths just to put a little dimple on it before actually starting the drill cycle. And I believe that's going to be a successful thing. So I'm just gonna, because at this point in the process, got a lot of work in these things, and I think I'll do a dry run. And just looking down here through the old eyeball on it, it's looking like it's in the right place and all looks well. So I think that was enough of a sanity check. Make me somewhat happy. Gotta make sure that every time I put in a part, the surface is clean, the reference surface is clean, I don't have chips or boogers. Okay, let's give this one a go. Coolant on. Gonna throw the old eyeball on it with finger on the stop button in case I have in fact, I'm gonna lower the shield here, get the eyeball in position. This one is one of the more picky ones. And yes, it worked fine. It's doing a full pack cycle, and I probably could change that to a fast pack. There's no reason that one has to be a full pack. So now we're going to be looking at the end hole, and that looks correct. That looks correct. And that's also doing a full pack. So it could probably be sped up by changing to a fast pack. When I first started using the machine, I did everything with full pack. And then little bit by little bit, as I got more comfortable with how things were behaving, I switched to fast pack for everything except the deepest holes. And that's looking really good. I think I'm going to have success here. Put the old tap magic on. And all is well. So except for the slight optimizations, I think this is fine, all is well. I'll make the optimizations and run the parts off camera. The fourth operation is to drill and tap a little perpendicular hole, and it's just so easy and so non-critical. It's just for a set screw that I'm going to do that one on the bridge port. So, real quick, get Mr. Heimer in place. Turn the servo on. And over here to the setup sheet, 758. And a little air. Probably grab a parallel. Probably grab another parallel. Unlike some of the other holes, the tapped holes on this part that are critical, this one is just a little set screw. And so I don't have to be as careful. And no need to power tap it. Just a set screw. I got a good eye for perpendicular. and a good feel for perpendicular. So that's the part. And got the hole, the hole, the hole. I'm going to run the batch. Then I'm going to put them in the vibratory polisher, knock another few numbers off the list, little bit by little bit. I'm pecking away at it. Thank you for watching. It's been fun.